Hey everybody, this is Larry. This is day 22nd of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm or today in general or whatever you like. And today's farm is going to be N Queens. I'm having like terrible allergies in New York this year. So if you hear me sniff a lot, that's why. That's my story and I'm sticking to it. Also, I'm solving these lives, so if it's a little bit slow or whatever, it is what it is. Just fast forward, watch it on 2x, whatever you need to do. So this one is N Queens. This, as you can guess, is probably going to be the stereotypical one. You have to return order this distinct solutions. What's a distinct solution? Okay. Yeah, I mean, I think because you have to return order solutions, you just have to kind of implement it in a good way. And one thing to note is that the worst case, given that n is equal to 9, it is going to be 9 factorial, which is only 362,000 you plug into a calculator. So then this is just way brute forceable, backtrack, is it backtrack? Yeah. Exhaustive search, if you will. There are a couple of clever ways to do it, but in the worst case, that's going to be the case. So yeah. I think that let's get started. We can do a couple of things to kind of speed that up. Now, first thing to know is that we just do it one row at a time, and then we can keep track of the column and the diagonals as well. So then we could, stop branching out in that way. So let's do that. And because you have to return the state, there's no way around it. You just have to do it, or like you just have to do the math, I suppose. But yeah, so let's have a recursive function, and let's have an answer array that's outside. Usually I do it a little bit less stateful. Sorry, I'm moving my eyes a lot because again, allergies. But yeah, so let's just have a self. Let's have a row, and that's pretty much it. We can keep track of the used columns, and we can use diagonals and just previous in general, because we have to reconstruct the state, so we have to keep track of it. And again, as we said, this is all just going to be backtracking. It's just about doing it in an easy way. So if row is equal to n, then we can take previous and add it to the answer. So yeah, answer that append. How do we want to say it? And I know that I'm a little bit messy right now. I didn't really define these to the viewer, but yeah. I'll get to it. No worries. Yeah, let's go. Let's say. What to think about? What's it called? The hardest part right now is for me to think about the names. Names are kind of tough, so let's just go string representation of previous, and then return. And otherwise, we do a for loop for column in range of rows. N, sorry. And then if column is not in used columns, and we can also try it, and we could do it in both, but yeah, the diagonal is equal to, so let's just do row minus column, because if you look at every diagonal, row minus column is, I guess it's two diagonals. I'm a little bit messy right now, but yeah. Knows 2. So the 2 is just basically for, every each way. So basically, if you look at a chessboard, there are two diagonals, right? There's one going upper left to lower right, and upper right to lower left. So you have two x's basically. One of them is going to be x plus y. X plus y will define the diagonal that it is in, and then the other one is going to be x minus y or y minus x, depending on how you infer it. So yeah, so if obviously if two things are on the same diagonal, then it is no good. What? Not. But yeah, now we can just do use columns dot add a column, use diagonals dot add dag. And of course, as we talked about earlier, the max case is going to be 362,000, and if you do a check at every time, that's only 3.6 million. So you can actually do it fast enough without all these fancy stuff. But I think I'm used to doing stuff like this with respect to just making it go even faster, especially on Leetcode or other platforms where sometimes it could get a little bit slow. So yeah, so all this is still going to be n factorial, but in actual running time will be much faster, ideally. Yeah, and then now previous dot add append. Whoops. Well, we can just do something like self row plus 1, use columns, use diagonals 2, and then previous plus column, something like that. And then of course after we're done, we should remove them back, and that should be mostly it, really. So then now we kick it off on row 0 and just sets an empty array, and then we just return answer. Of course we have to do the string representation thing. Because now we have an array of indexes. Man, my allergies is really preventing me from talking. My apologies. But yeah, you have an array of indexes and you want to return it to convert it to this thing. So yeah. So yeah, let's just say s is equal to an array. So for row in board, or for column in board, maybe it's a little bit awkward. So then now it is just s is the s dot append this times column minus 1 plus the green plus this times n minus column minus 1, something like that. Maybe I'm off by 1 here, but that's just my intuition. Let's kind of give it a, I think this is off, this should be off minus 2 maybe. This is just really off, clearly. Because for 4, it doesn't even return all the answers. Let's see. On this 0 of 1, okay. Yeah, no, this should be this. Okay. This is better, but still, okay. Maybe this was right the first time, and I'm really bad at math or counting. Okay, so this looks better. I actually turns out that I produced it in the same way that they did, but yeah, and in this case, because there are only 9 possible inputs, I recommend just running it just to see the running time maybe, but yeah, you can kind of see that it turns out that I think we produced in the same order, which is lexicographically shorter, I suppose, and 1 in 84 milliseconds, so that's going to be good enough for me to give it a submit. But in any case, this is still going to be n factorial. It's just that n is 9, so, and as we talked about it, 9 is not that big. And you could have done it without all these fancy things, maybe. You can actually just, like if you wanted to do it sloppily, maybe you could have done something like this, and then so then you would have row of row plus 1, and then your previous plus but it's gonna be much slower. And then here you do some checks on the previous instead, so you would maybe do something like, you know, for column 1 in previous, I don't know, like you just you do some check here. I'm a little bit lazy today because allergies is kicking me hard. So yeah, but yeah, anyway, the space complexity, this solve is going to be at most n rows deep, so the extra space is going to be O of n. I mean, I do also use a bit of extra space, but that's all O of n in terms of these. In terms of extra space, because here the result is always going to be at the worst case n factorial, kind of, because in practicals doesn't happen anymore, but yeah, in practical terms, I don't know how many actual valid configuration there is, but in theory the worst case is going to be n factorial space, which is output sensitive, right? You're only outputting as much as there are actual answers, so you can't really do better than that either. Cool. That's what I have for today. My allergies is really bad. I apologize if it's a little bit harder to follow than usual. I'm having trouble talking, and it's kind of hard to do a video when you can't talk that much. I'll do some, I mean, and you know, you could watch this on mute, I guess, if the sound is terrible. Anyway, I'll see you later. Hope you had a great week. Hope you know, have a good weekend and do the contest coming up and all that stuff. And I will see you later. Take care and good mental health. Bye bye.